Researchers have developed an AI framework that allows humanoid robots to execute advanced athletic maneuvers with exceptional agility. Carnegie Mellon University and NVIDIA have partnered to create aligning simulation and real physics, or ASAP, that allows humanoids to execute moves like Cristiano Ronaldo's iconic mid-air spin and Kobe Bryant's signature fadeaway jump shot. The two-stage framework addresses dynamics mismatch by pre-training motion tracking and simulation and refining policies with real-world data, using a delta action model to align effectively with real-world dynamics. For years, researchers have aimed to develop humanoid robots with human-like agility, but most efforts have focused on locomotion rather than full-body athletic movements. Recent studies have introduced upper-body expressiveness, yet achieving whole-body agility remains a challenge due to hardware limitations and discrepancies between simulated and real-world physics. To bridge this gap, three main approaches have emerged: system identification, SysID, domain randomization, DR, and learned dynamics methods. SysID estimates key physical parameters but relies on predefined spaces and torque measurements, limiting its adaptability. DR trains policies in simulation with randomized parameters but can result in overly cautious movements. Learned dynamics models use real-world data to improve accuracy but remain unexplored for humanoid robots. To address these limitations, the team proposes ASAP, a two-stage framework for agile humanoid whole-body skills. First, policies are pre-trained in simulation using human motion videos. These are retargeted to humanoid robots and trained with a motion tracking policy. Since direct deployment leads to performance loss, a second stage collects real-world data to identify discrepancies. A delta action model is then trained to compensate for these differences. Finally, the policy is fine-tuned with the delta model, allowing humanoid robots to adapt effectively to real-world physics. The learning process enables humanoid robots to bridge the gap between simulated training and real-world execution, pushing the boundaries of robotic agility. An ASAP-trained humanoid robot can now replicate signature moves from sports legends, including Cristiano Ronaldo's shoe celebration with a mid-air spin, LeBron James's silencer with precise single-leg balancing, and Kobe Bryant's fadeaway jump shot. Beyond sports moves, it can also perform forward and side jumps exceeding 1 meter. While the robot may still appear clumsy due to hardware limitations and fewer articulations than a human, it demonstrates significantly improved dexterity compared to previous humanoid robots. The advancement is largely due to the delta action model, which compensates for differences between simulated and real-world physics. By integrating this correction mechanism, researchers reduce tracking errors by up to 52.7%, allowing the robot to execute complex whole-body motions previously unattainable. Future research could focus on creating smarter control systems to protect the robot from damage, using cameras and sensors instead of motion capture systems, and improving learning methods so robots can quickly adapt with less training data.